There are places in the solar system that look unspectacular at first glance, but in reality, they're absolutely crazy. Titan is one of the 274 moons of Saturn known to us, and it fits exactly into this category. A moon larger than the planet Mercury, with a dense atmosphere, with lakes, rivers, and rain, with dunes and coastlines. Only it's not made of water, but of liquid methane and ethane. If you had to look for a place that feels the least like a dead rock in space, Titan would be right at the top of the list. And that's exactly where National Aeronautics and Space Administration wants to land. Not with a rover or a traditional probe, but with something that sounds more like it's from a science fiction movie, a flying nuclear helicopter called Dragonfly. My name is Serwin, and this is Mars Chronicles. But let's start from the very beginning. What exactly is Dragonfly? This probe is a planned National Aeronautics and Space Administration mission as part of the New Frontiers program, which is the same mission class as New Horizons or Juno. These aren't small probes. These are real flagship missions of the mid-range class. The official plan looks like this. The launch is currently scheduled for mid-2028. And the nuclear-powered helicopter is supposed to arrive 6 years later in 2034 on Saturn's moon. Yes, you heard that right, 6 years of travel time, because Titan is far away, very far away. And when Dragonfly arrives there, it doesn't just land and stay put. It will fly again and again from place to place, like an autonomous scientific explorer helicopter on a foreign celestial body. The basic idea behind it is ingeniously simple. Titan is much too large, much too diverse, and much too fascinating to study it from just one spot. A classic rover would be extremely limited there, while an orbiter can see a lot but can't touch anything. So National Aeronautics and Space Administration came up with something completely new. A probe with 8 rotors powered by a nuclear generator that hops across the surface like a mix between a drone and a mini spaceship. Flight by flight, landing site by landing site, kilometer by kilometer. Write in the comments if you know which helicopter was the first to fly on a celestial body other than Earth without Googling. But why Titan of all places? What makes this moon so special that National Aeronautics and Space Administration is willing to invest billions of dollars and decades of work? The short answer to that is pretty counterintuitive. Titan might be the most Earth-like place in the solar system, apart from Earth itself. It has a dense atmosphere, mainly made of nitrogen, just like Earth itself. It has weather, rivers, lakes, and rain. But not made of water. It's made of liquid hydrocarbons. And above all, Titan is a gigantic natural chemical factory. On its surface and in its atmosphere, chemical processes take place that are very reminiscent of early Earth, a time before life arose here. Many scientists therefore suspect that if we want to understand how simple chemistry can eventually become biology, then this moon is one of the best laboratories that nature offers us. In short, Mars is interesting because it was once Earth-like. Europa and Enceladus are interesting because they have oceans beneath the ice today. And Titan is interesting because it might show us how life could arise in the first place, but in a completely different chemical environment. And that's exactly why a simple camera probe isn't enough there. You have to directly examine it, the soil, the dunes, the organic deposits, and the chemistry. And that brings us back to Dragonfly. Titan is also the perfect place for a flying mission because the conditions there are almost ideal. The gravity on Titan is only about 14% of Earth's gravity. At the same time, the atmosphere is denser than on Earth. That means a lot of lift and little weight. Or to put it another way, you need much less energy to cover the same distance as here on Earth or on Mars. A helicopter that can barely fly on Earth would suddenly be extremely efficient on Titan. It's exactly this physical coincidence that makes Dragonfly possible in the first place. So you could say, Titan is the dream of every engineer who wants to build and fly a drone in the solar system, and National Aeronautics and Space Administration is taking full advantage of that. What exactly Dragonfly is supposed to investigate, which instruments are on board, how the mission will actually proceed, and why Titan might even provide clues to exotic life forms, that's what we're going to look at now. What exactly is Dragonfly supposed to do when it arrives on Titan in 2034? Because just flying around and taking pictures would be a bit too little for a billion-dollar mission. The mission has three main scientific core objectives. One, to understand the chemical composition of the surface. Titan is covered with organic molecules, that is, carbon compounds, which in their complexity partly resemble the chemistry from which life on Earth originated. Dragonfly is supposed to analyze exactly these substances, not from orbit, not from a distance, but directly on site. It lands, takes samples from sand, rocks, or frozen deposits, and examines them in the onboard laboratory. The central question is, how complex is Titan's organic chemistry really? Are there perhaps even molecules there that could be considered precursors to biological processes? The geological history of Titan holds the key. The moon looks incredibly diverse in radar images. There are dune fields, riverbeds, possible ice volcanoes, lakes of methane and ethane, and vast plains that are probably made of frozen organic deposits. Dragonfly will fly to different regions, compare them, and try to answer the following questions. Are these landscapes young or old? How active is Titan today? And are there geological or titanological processes that might even bring material from the interior to the surface? All of this helps us understand Titan not just as an exotic moon, but as a complex, dynamic world. And third, perhaps the most exciting goal, the mission aims to find out whether Titan offers conditions that could, in principle, be hospitable to life. And not for life as we know it, but for completely different forms of chemistry-based life. Because Titan is so cold that water there is as hard as rock. Life on Titan, if it even exists, would have to function completely differently from anything we know so far. That's why Dragonfly is searching for prebiotic processes, chemical reactions that could be a step toward biology. It's not about finding little green Titan inhabitants, but about understanding whether nature can take steps toward life even under completely alien conditions. Although we shouldn't turn a blind eye to green Titan inhabitants. To achieve these goals, Dragonfly is equipped with a whole range of highly specialized instruments. The centerpiece is a compact chemical analysis lab, an instrument called Dragonfly Mass Spectrometer, which stands for Dragonfly Mass Spectrometer, in other words, a mass spectrometer. With this, the probe can heat samples, vaporize them, and determine their molecular composition with extreme precision. Basically, it's a small chemistry lab on 8 rotors, or rather, between 8 rotors. In addition, there's a gamma-ray and neutron spectrometer which measures the elemental composition of the soil, that is, what the ground is actually made of. There are cameras for navigation and science, meteorology sensors for wind and weather, seismic and geophysics instruments, and of course, a system for collecting samples. So, Dragonfly is less of a drone with a camera and more of a flying rover with a laboratory. But how does such a mission actually work in practice? That would be far too energy intensive, even in the dense atmosphere. Instead, the whole thing works in stages. The probe lands at a selected location, conducts measurements there over days or weeks, and collects the data. And when everything is done, it takes off again and flies to the next destination. Each flight will only be a few kilometers long, but over the entire mission duration, this adds up to an enormous range. The current plan is for Dragonfly to cover hundreds of kilometers on Titan in total, something that would have been completely unthinkable with a traditional rover. Dragonfly has a landing mass of about 450 kilograms. On Titan, Dragonfly feels as if it only weighs about 58.5 kilos. And this is where it gets really interesting from a physics perspective, because this low weight also means that Dragonfly only needs 13% of the thrust on Titan that it would need on Earth. So the rotors have to generate much less lift in order to take off. At the same time, Titan's atmosphere is about 4 times denser than Earth's, which means that every square meter of rotor surface provides much more lift there than it does here, less gravity, and more air density. That's an almost perfect combination for flying. In principle, Titan is a real paradise for flying, while on Mars it's exactly the opposite with its extremely thin atmosphere. That's why Ingenuity has to use huge rotors and very high speeds, while Dragonfly can get by with comparatively compact rotors, moderate speeds, and significantly less energy. With its Titan design, it probably couldn't even take off on Earth, but on Titan it becomes the ideal exploration machine. More density means more countermass you can push against. That's exactly why a person can float relatively easily in water, but hardly at all in air. This makes the rotors extremely efficient. I find that incredibly fascinating, which is why I talk about it so much. As an energy source, there's no solar panel on Titan. That would be pointless. Way too little sunlight. That's why Dragonfly uses a nuclear radioisotope generator similar to Curiosity or Perseverance on Mars. This generator reliably provides electricity and heat for many years, making the mission independent of time of day, season, or weather. Without nuclear energy, a project like Dragonfly simply wouldn't be feasible. Another particularly interesting point is the planned landing site. National Aeronautics and Space Administration has chosen a region called Shangri-La, a large dune field near the Selkin crater. Shangri-La is this dark spot in this image. Scientists suspect there is an exciting mix of ancient organic deposits and material that was altered by an early impact. In short, a perfect natural laboratory. If everything goes according to plan, Dragonfly will be the first mission in history to deliberately fly from place to place on another celestial body and actively explore different environments. This isn't just another probe, but a completely new kind of planetary exploration. And that brings us to two big questions in the next part. How realistic are the timelines really? And what does Dragonfly mean for the future of space travel, even beyond Titan? So far, Dragonfly sounds like one of those missions where you wonder, why haven't we done this a long time ago? A flying laboratory on Titan that can travel hundreds of kilometers, perform chemical analyses, and explore a completely new world. Scientifically, it's almost a dream project, but that's exactly why it's also one of the most challenging undertakings National Aeronautics and Space Administration has ever launched. Let's take a look at the schedule and the risks. Officially, Dragonfly is scheduled to launch on a SPACEX Falcon Heavy in 2028. The flight to Saturn will then take about 6 years, so arrival in the Saturn system would be in 2034. That sounds far away, but in spaceflight terms, it's basically tomorrow. Because the hardware for such a mission isn't built just 2 years in advance. Development is already in full swing and the schedule is ambitious. Dragonfly isn't a classic lander that you test once, pack up, and send off. It's a complex flying machine with movable rotors, autonomous navigation systems, a mini chemistry lab, nuclear power supply, and a landing technology that has never been used on another celestial body before. That means many of the technologies are being used in exactly this combination for the first time. And that brings us to the risks. The biggest risk isn't the launch or the flight through the solar system. The biggest risk is the moment when Dragonfly is supposed to take off from Titan for the first time. We're talking about an autonomous flying device that's 1.4 billion kilometers away with a signal delay of over an hour. If something goes wrong, no one can intervene. That's why Dragonfly has to function practically like a little robot pilot. Recognize terrain, avoid obstacles, and find safe landing spots all completely independently. This is technological new territory, and then there's the environment itself. Titan is flight-friendly due to its atmosphere and lower gravity, but it's still extremely alien. Minus 180 degrees Celsius, unknown surface conditions, possible storms, fog, electrostatic effects, and definitely some unexpected things as well. No one has ever tested a vehicle like this under real Titan conditions, since you simply can't recreate Titan on Earth. That's why Dragonfly is, in a way, an experiment in progress. Still, National Aeronautics and Space Administration is unusually optimistic. And there's a reason for that. Dragonfly builds on decades of experience. Cassini mapped Titan from orbit. The Huygens probe successfully landed on Titan in 2005 and provided data about the atmosphere. The Mars helicopter mission Ingenuity has shown that autonomous flying vehicles on other celestial bodies are realistic. Dragonfly is, so to speak, the logical next evolutionary step, and that makes it clear why this mission is so important. Titan is one of the few places in the solar system where the chemistry is so complex that it resembles early Earth. If we want to understand how life originates or could originate, then Titan is one of the best natural laboratories we know. So Dragonfly is not just another probe. It's an attempt to bring us a little closer to answering one of the greatest questions in science. How universal is life really? And now, a quick look at our sponsor today fits surprisingly well, because while National Aeronautics and Space Administration is searching for traces of alien chemistry on Titan, our sponsor is dealing with exactly the question of what contact with an alien civilization might look like. However, from a very human perspective. Today, this video is supported by Constantin Salatay and his science fiction series, The First Contact Crisis. The latest volume, Mirror Images, concludes this series for now. A large part of the story even takes place on a Saturn moon, Mimas, the famous Death Star moon. Thematically, it's exactly about what makes missions like Dragonfly so exciting. What happens when humanity and alien worlds meet? What scientific, political, and psychological consequences would a real first contact have? Starting in early February, the entire series will also be available as audiobooks on all major platforms for anyone who wants to listen in advance. The first chapter is available for free on Constantin Salatay's YouTube channel. Of course, you'll find the link below in the description. So if you're interested in intelligent, technically sound science fiction that fits perfectly with this video about Titan, be sure to check it out. Many thanks to Constantin Salatay for supporting this video. Back to Dragonfly. What does this mission mean for the future? If Dragonfly works, it will open up a completely new category of planetary research. Imagine flying probes on Venus, autonomous drones in the canyons of Mars, exploration vehicles on Enceladus or Europa that hop from place to place. Dragonfly could be the prototype for an entire generation of new missions, and that's exactly what makes this project so exciting. It's not just a journey to a distant moon, it's a test run for the future of space travel. If everything goes well, in the 2030s, we'll not only visit an alien world for the first time, but really explore it actively. Place by place, sample by sample, flight by flight. Write to me in the comments, do you think we'll one day find traces of prebiotic chemistry on Titan? Or will Titan remain just a fascinating but lifeless laboratory? My name is Serwan, and this was Mars Chronicles. Thanks for tuning in. Per aspera ad astra.